So as I was talking about the OFDM transmitter output, we can see from figure 1 and 2. This is the result of the operation that we just did on our OFDM transmitter block. And we can see that the signal carrier uses T by 2 as its time period. You can also notice that um, this is the plot in the time and the frequency domains. We can notice that the carriers is the discrete time baseband signal. We could use this signal in baseband discrete time domain simulations. Now the first step is to produce a continuous time signal to apply a transmit filter GT to the complex signal carrier. Now the output plot of the impulse response of the filter response is here. You can see this. This is the impulse response or pulse shape of GT. The output of the transmitter filter is shown by figure 4. This is in time domain, and in figure 5, which is in frequency domain. Now we can see that the frequency response of this figure is periodic as required of the frequency response of a discrete time system. So the first thing to notice here is the delay of approximately 2 into 10 raised to the minus 7 produced by the filtering process. Aside of this delay, the filtering performs as expected since we are left with only the baseband spectrum. So now I will run my code for the MATLAB simulation to investigate the effect of the PAPR on OFDM signals and the clipping techniques used to overcome its effect. This is my MATLAB code for that. Now I'll run it. So now I have got here what I'm doing is I'm generating okay. So this is my OFDM signal that I'm trying to transmit. I'm trying to transmit data by two ways, through a normal OFDM signal and through a signal which has been clipped by using the clipping technique, which can be shown from the figure 4. So the transmitted data is being transmitted one by through an OFDM signal and through a clipped signal. After passing through the high pass filter, the output plot of the normal OFDM signal is something like this. And the same response of the from the HPA high pass filter of the clipped signal is this. So we can see that in this plot there are several peaks which are higher than the average peak power values, which means this plot shows the high PAPR problem, which is in our normal OFDM signal. But in the clipped signal, there are very few values which are greater than the average power values. Most of them are in the average. So we can see by using the clipping technique, I have basically removed the effect of the PAPR. And on the receiving end, the data that will be transmitted at the receiving end with something like this for our normal OFDM signal, and like this for our clipped signal. So now we go back to our PPT presentation. So you can see I have put all the plots for the OFDM transmitter as well as the PAPR versus clipping technique over here. So in the conclusion, I basically explained in this video that OFDM is a key modulation technique in the wireless communication. I explained the basic idea and orthogonality. Then we discussed about the OFDM communication system, how it works, and how the OFDM signals are generated using IFFT blocks. Then I talked about advantages and disadvantages of OFDM. The biggest issue of the OFDM signals is the PAPR problem, which is the average power problem, power issue, and this is a big issue in OFDM modulation, and we can solve this issue by using the clipping technique. So then I moved on to simulation of the OFDM transmitter in MATLAB environment, and then I showed the results. Then I showed the MATLAB simulation effects, which displays the effect of the PAPR in OFDM, and also the effect of the clipping technique to reduce the PAPR. So overall, as my result, you can see from the plots which like I showed from the plots that our signal after clipping is very good as compared to signal before clipping, because before clipping there is a high PAPR problem which is being removed by the clipping technique. Hence, it's an efficient technique to solve a problem or disadvantage of OFDM communication system. Thank you.